Welcome to this explainer. Have you ever looked down at your dinner plate and wondered exactly how those specific ingredients ended up there? It's actually a massive, incredibly complex puzzle. Today, we're diving right into a fundamental question about how humanity decides what grows where. We're going to shift our perspective from this perfect, highly mathematical 19th century map of the world all the way to the messy, deeply human territory of modern agriculture. We'll be looking at two very different ways of understanding land use, blending some classic economic geography with some really cutting-edge modern research.
So let's get right into it. What actually decides what grows where? If you're looking out the window on a long cross-country train ride, you'll see patches of vegetables, then vast fields of grain, and maybe a dairy farm way off in the distance. Why are they organized in that exact way? Well, for a long time, economists thought they had the absolute perfect, mathematically precise answer to this. But as we're going to see, we really have to ask ourselves, in our modern age of global supply chains, does a farmer truly make decisions based solely on the cost of a horse-drawn cart?
To understand the original blueprint of agricultural geography, we actually have to rewind a bit. Let's travel back in time to the year 1826, specifically to an estate in Mecklenburg, Germany. Here, a guy named Johann Heinrich von Thunen created a totally foundational model of land use. And honestly, it was completely revolutionary for his era. He was one of the very first people to use rigorous math and spatial economics to explain exactly why farmers plant what they plant, based entirely on where they're located.
The core concept von Thunen came up with is called locational rent. Basically, this is the economic value you get from a piece of land based on three pretty simple variables: how far it is to the market price of the good itself, and the cost to transport it. It's a brilliant calculation, but you have to remember that his model relied heavily on the assumption of an economic man. This is a perfectly rational farmer who makes choices in a total vacuum just to maximize profit. He also imagined an isolated state. So picture a world with entirely uniform physical conditions, perfectly flat land, homogeneous soil, and just one single central market city driving all the demand. Operating on those very strict assumptions, he visualized agriculture as a series of perfect concentric rings wrapping around that central city. And the logic he used for these zones is actually quite beautiful. Right next to the city, in Zone I, you've got dairy and market gardening. Why? Well, because milk and fresh veggies spoil super fast and are expensive to transport quickly. Move out to Zone 2 and it gets really interesting. Forestry for firewood. In 1826, wood was an absolute necessity for fuel and building, but it's incredibly heavy, which means transport costs were enormous, so it had to be close by. Further out in Zone 3, you get your extensive grains like rye and barley, which don't spoil quickly and are much easier to transport in bulk. And finally, way out in the outermost ring, Zone 6, you have livestock ranching. The logic here was pretty brilliant for the time. Animals obviously don't spoil easily, and, best of all, they literally provide their own transportation by walking themselves to the market. Moving on to Section 1, breaking the rings. Okay, so von Thunen's model was this beautifully logical system where transport costs dictated absolutely everything. And, for a very long time, it made a lot of sense. But as the Industrial Revolution kicked into high gear, those perfectly drawn concentric circles began to warp, blur, and ultimately just shatter. The model totally broke down when we introduced modern realities. Instead of an isolated state with horse-drawn carts and a single market, we now have complex global networks, refrigerated trucks, and massive multi-city markets. Suddenly, highly perishable milk doesn't need to be produced right outside the city limits anymore. It can be flown or driven across an entire continent in a cold chain. The strict mathematical rules of distance and perishability that built those perfect rings were entirely overcome by modern technology. On top of that, the physical limitations of the land itself were fundamentally altered. Take India, for example, where the model's expected zones were heavily disrupted by massive modern agricultural interventions. The introduction of tube well irrigation and high-yielding variety seeds during the Green Revolution meant that farmers could suddenly practice highly intensive agriculture in distant, remote zones that von Thunen would have definitely reserved for extensive ranching. It was a huge shift in land management. And when you add in complex government interventions, pricing policies, and heavy subsidies, the pure profit-maximizing math of that 1826 model gets completely turned on its head. Which brings us to Section 2, the human flaw. You see, the biggest issue with viewing farming purely through this mathematical, economic lens isn't just about refrigerated trucks or government subsidies. It's what we might call the human flaw.
The classic model completely ignores the messy, real-world struggles of real people, their local communities, and the deeply entrenched power structures they live in. This brings us to a vital modern paradigm shift in understanding land use, known as political ecology. This interdisciplinary framework argues that agricultural land use isn't just about the physical distance to a market or the raw cost of transport. It deeply examines how power, history, governance, and access to resources actually intersect with our ecological systems. It asks a much more profound question, really, not just what is most profitable to grow here, but who actually has the power to decide what grows here.
Let's look at some contemporary research to understand just how crucial this shift in thinking really is. In a major revelation from her 2024 paper, Dr. Sakila Haque points out that dominant sustainability models today are still making the exact same mistake von Thunen did back in 1826. They focus entirely on the math. She notes that interventions frequently prioritize technical efficiency and market-based solutions while completely overlooking the structural, political, and economic forces that actually shape land use practices. The absolutely crucial takeaway here is that when we obsess over technical fixes, like engineering a slightly better seed or optimizing a supply chain, we completely miss the underlying power imbalances that are driving rural inequality and environmental degradation in the first place.
This perfectly illustrates the divide between the map and the territory. Abstract economics lives in this mathematical vacuum of profit maximization, absolute distance, and uniform conditions. It looks really good on paper. But political ecology grounds us in tangible reality. It forces us to look at the stark, real-world contrast between local communities practicing highly localized, sustainable smallholder agroecology and the intense, often devastating pressures of large-scale corporate land grabs driven by neoliberal policies. That isolated state simply does not exist. Real farmers are actively navigating incredibly complex global power dynamics every single day, often struggling just to hold on to their land and their livelihoods. And that brings up a wonderfully provocative question raised in Dr. Hawk's research. Are modern agricultural interventions actually climate smart, or are they just business smart? Her findings reveal that without addressing those deep structural inequalities we were just talking about, even well-intentioned sustainability initiatives can completely backfire. Think about it. If a new, supposedly climate-smart technology is incredibly expensive and only accessible to wealthy, large-scale landowners, it can inadvertently fail marginalized groups. It can push vulnerable smallholders right off their ancestral land, or even worsen environmental degradation by overriding the local, historically grounded farming practices that have literally worked for generations. Let's head into our final part, Section 3, Reimagining Agricultural Futures. So how do we actually move forward from here? To truly achieve sustainable rural development and ensure food security for a growing global population, we have to stop relying entirely on abstract economic maps and instead use political ecology as a guiding tool to fix the territory itself. This builds a very clear framework for a genuinely resilient future. First, we must actively acknowledge the structural power imbalances in land tenure and resource access. We just can't pretend everyone is starting on a level playing field. Second, we've got to foreground justice and equity, placing human well-being above mere yield and profit. Third, we must integrate local, place-based knowledge rather than arrogantly imposing a one-size-fits-all technological solutions from the top down. And fourth, by doing all this, we can design inclusive, participatory policies that make our agricultural systems resilient for everyone involved. And that brings us to the end of our explainer today. We've stepped far outside of Johann von Thunen's beautifully simple, mathematically mapped concentric rings, and into the incredibly complex, unequal, and deeply human political reality of today's land use. As we look ahead at the future of our planet and consider exactly how we're going to feed billions of people sustainably, we're left with one really critical question to ponder. Are we farming for maximum profit or maximum equity? Thanks so much for joining me on this journey through the landscape of agricultural geography. Keep asking questions and keep learning.